tool Inmon. I haven't tested that. It's commercial, so I don't know how exactly it's working, but I've heard rumors as well that they're processing each packet, storing it, and that it's not really scaling on a bigger platform. Yeah, so the issues in the end I had with the software was that each sample is stored, and even if you have even if it's sampled, I mean, we have, and that's actually on the next, I go back in a second, when we have 35 million packets per second with a sampling rate, I think, of 8K or something, I don't know if I even counted that correctly, you still have 3,500 samples per second you have to write down somehow, and that is quite a lot, and that is, it was not easy to do that. So that's why, back? Yes. Yeah, so that's why these options with to use some of these programs were not doable. So the ideas we had was to pre-process that up front, and another thing is you want to see graphs in the end. You don't want to see tables of databases with numbers in it, fancy, shiny graphs showing you something about the traffic. So almost everybody was using RDTool in the end to make some graphs out of that. But in the end, RDTool is a database again. You don't really need to store that in MySQL, Postgres or something and then put it again into RD files, and you have the data, you have to save it twice. So we thought something up to first analyze this stuff and then put it directly into an RD database to reduce the overhead we have through sampling, to writing these things twice. Okay, into that. So I started writing the software, and we were discussing for a while what we should do and how we should do that. And in the end, we figured all the tools out there, all the open source tools are written in C. And in the end, we thought, yeah, let's have something we can, I don't know, which might be for some people, I don't want to say anything wrong, but we decided in the end that it might be for us easier to have something in Perl, which we can easier script or do different things with it, different analysis types, and so on. Perl is kind of flexible because a lot of modules are already there. You can just open your UDP sockets and things like that, so you don't have to rewrite all this stuff. But one thing was missing, and that was the SFlow decoding module. So we had to start out with writing a module to actually decode the SFlow data. Basically the datagrams I was showing earlier. Yeah. So this NetSFlow thing is open source and it's on CPAN. We published it a couple of months ago. It has only one function, decode, and you can put a SFlow packet in there, and it's returning a structure of arrays and hashes with all the information which is actually in the SFlow sample. It was kind of difficult because there's a lot of stuff in there, and the documentation is basically 5 pages out of what kind of hash keys you get back and how you can, and what kind of information you actually get. And there's quite a lot, but it's still useful because it's quite handy to have that in a structure. You can just go through and put it somewhere again. So that was the first thing, and that was working a couple of months ago. So then I had to go on, and I wrote a sort of a daemon around it, which is not really, it's not open source yet and it's not finished yet, but we're working on it. The thing is, it's quite hard to make that more usable for everybody. It's specific for the type of analysis we are doing on the platform, and it's, I'm still thinking about some ways how to make it more usable for other people as well. But it always depends on, for example, not everybody has this the structure of one MAC address per port, and we filter by MAC addresses, but some other exchange or some other company might not that might not be useful for them, like it was here on the Congress, that it didn't make any sense to sample or to filter the traffic by MAC addresses. So I have to think something up how to make that more usable. So I'm receiving the packets there, I'm analyzing them, and this thing is automatically putting it into RD files, so we don't have any other databases in between. And it was quite nice performance-wise, because we have way less I/O due to the pre-processing. And yes, Perl unpack is kind of a bit slower than C, but it's still way better for our purposes than all the other things out there. Just to have a look at that's the CPU graph from our collector server running on AMSIX. And it depends on the amount of packets or on the amount of samples you get in the end, how much CPU we're using. But we can deal with that so far. So. Dan, yes.
How many samples per second are you actually receiving with your Perl implementation?
You came late. I already mentioned that. I think we have 3,500 up to 4,000 samples per second right now. And with the total packet rate on the exchange is up to what was in there? 35 million packets per second, and we sample with a sampling rate of 8K. So of course, if you lower the sampling rate, you have twice as much samples, and then the CPU would go up again. But I do have some results about the accuracy of this stuff later on, and it's quite amazing. So we don't really need to have a higher sampling rate, a lower sampling rate to have more samples right now. Okay, let me say some things about privacy. So we have this whole packet header in the end, and okay, it is statistically, and you only get 1 out of some samples, but still you could do some payload analysis on that. So the thing is, at AMSIX we only operate on layer 2, so we didn't really want to decode more. So in the end, this NetSFlow module is not really returning anything more. I'm only decoding the packets up to layer 2, and of course, the whole packet data is in there, and it's not too difficult to rewrite it that you have the whole structure, and then you can just decode that by yourself. But we just decode the Ethernet header, and that's, in the end, all we need for that. And another thing is, by not writing all the data down into a database, we just don't have all the information. It always depends on what is actually in the code right now and what we want to analyze to have it. So we don't store the whole packet, and we cannot look later on at the payload or stuff like that. If we decided now to not have more than layer 2, and we only have the layer 2 information in the RD database files, and that's it. So everything else gets thrown away immediately after it arrives in that software. Same for this conference here. We are going to see the graphs later, so I added a couple of more things how to analyze this data, but in the end everything else gets deleted. Not even deleted, because it was never really there. So. Okay, shiny graphs. Okay, a couple of graphs from the AMSIX, and in the end I'm going to show the conference graphs. Multicast traffic. So I'm filtering by multicast traffic, and if somebody is doing something wrong on a platform, even though I have to admit I haven't figured out what that was, but it stopped after 24 hours, so something was wrong. We see a peak, and we can do quite some stuff to figure out if we actually have problems or not on looking at graphs like that. We have the same for broadcast traffic and for different types. Okay, let's go on. IPv6 traffic. We do have up to 180, 160 megabit per second of IPv6 traffic on the Amsterdam Internet Exchange. These dips every 24 hours are quite interesting because as far as I know by now, I'm still not really sure about that. This traffic is mostly caused by news providers, and these news providers are updating their services every 24 hours, and you cannot fetch any news anymore, so that's why this IPv6 traffic is going down every 24 hours and at the exchange. The next one is an example for member-to-member statistics. Oh, I forgot to mention something. SFlow is sampling on the port, and it's only sampling incoming traffic on the port. So that's why I never have in and outgoing traffic. But in that case, if I sample something if I want to map MAC addresses behind two different ports, then the traffic coming in on that port going to this MAC address is sort of the outgoing traffic for the other port, which is going to that side. So we just assume that what's coming in here, going there, is the outgoing traffic for the other way around, and that's why I can show outgoing traffic in graphs like that as well. Yeah, just a couple of examples what we actually see from member graphs. Accuracy. So at some point I was interested in actually having some information about is this stuff accurate or isn't it? The graph on the right is from the counters made by MRTG, and the graph on the left is from SFlow by only looking at 1 out of 8K samples. And it is pretty much the same. Was at the same time? It was, or yeah, almost. Usually I have the impression that SFlow is always a little bit more, but things like that also depend on packet size distribution and things like that. So when I get one packet, I'm looking at the size, and I just assume that all the 8K minus 1 samples I haven't seen during that are the same size. So if the packet size distribution is different than the packet size distribution in the samples I have, that causes errors, of course. It's statistics, so it cannot really do better, but I think it's pretty okay for what we actually want to do with that, because we are not going to, we don't want to do any billing or whatever with that. It's just information to know who's peering with who and what kind of traffic we have. Same thing for one specific interface of one member connected to M6. Also pretty nice because all the dips there and in the middle are exactly the same. So it seems to work pretty well.
I have a quick question for you. You
Sure.
said that you're only looking at incoming traffic.
Yeah, I just said that. SFlow is only sampling incoming traffic.
Okay, what would the benefit be of looking also at outgoing traffic?
Sorry?
What would the benefit be of also looking at outgoing traffic?
The benefit?
Would there be one?
I don't really think so, no.
Okay.
No. There's a lot of people are asking when we put these graphs on the website, and a lot of people are asking like, oh, why is that only green? I missed the blue line. They're used to that or something like that. Because it would be, in the end, it would be exactly the same, because what is coming in on one port is going out on the other port again. Or at least it should be like that if the switch is not dropping packets or something. So.
Who has access to these graphs that shows MAC-to-MAC statistics?
The members.
All the members have access to
No,
all?
only the members have access to their specific graphs.
Okay, thank you.
It is, yeah. Of course, people don't want to have their peering information online somewhere, so that's kind of obvious. But to have information about, I mean, if you want to know something about your peering, you always have to have the second party. So, of course, you see your traffic going to a couple of different people, and that's it. On the website, publicly, we have the broadcast analysis, the multicast analysis, and the IPv6 analysis. That's pretty much it.
here. You mentioned that the blue line should